Chapter 3 Square and Square Roots I Enrich 1 Part 2. Before solving this, subscribe to Mohanraj Ganapathy and share it with your friends. Sum number 10. Express the squares of the following numbers as a sum of two consecutive positive integers. There is a property for representing a square as a sum of two consecutive positive integers. Suppose if a number is n, we need to find n square, then sum of two consecutive numbers is like this, plus n square minus 1 by 2. In this manner, we have to represent A subdivision 23. 23 square is equal to, here n is 23. So 23 square plus 1 by 2 plus 23 square minus 1 by 2. First of all, we need to find what is 23 square. 23 into 23, 9, 6, 6, 4, 529. So 529 plus 1 by 2 plus 529 minus 1 by 2. 529 plus 1 is 530 by 2 plus 529 minus 1 is 528 by 2. 530 divided by 2 gives us 265 plus 528 divided by 2, 264. So they asked us to find two consecutive numbers. So 264 plus 265 gives us the square of 23 square. B. 55 square, this can be written as 55 square minus 1 by 2 plus 55 square plus 1 by 2. First of all, we need to find 55 square. 55 into 55, 25, 25, 26, 27, 275, 5, 2, 10, 3025. 3025 minus 1 by 2 plus 3025 plus 1 by 2. 3025 minus 1, 3024 divided by 2 plus 3025 plus 1, 3026 divided by 2, which is equal to 1512 plus 1513. So on adding 1512 and 1513, we will get 55 square. C. 107 square can be written as 107 square minus 1 by 2 plus 107 square plus 1 by 2. 107 into 107. 7 sevens are 49. 7 into 0 is 0. 0 plus 4 is 7. 1 into 0 plus 4 is 4. 1 into 7 is 7. 1 into 7, 7, 0, 1. So 11449. 11449 minus 1 divided by 2 plus 11449 plus 1 divided by 2. So 11448 divided by 2 plus 450 divided by 2. Our answer is 5724 plus 5725. Is it clear? D subdivision. 131 square can be written as 131 square minus 1 by 2 plus 131 square plus 1 by 2. First we need to find what is 131 into 131. 1 times as it is, 3 into 1 is 3, 3 3s are 9, 3 1s are 3, 1 3 1, 1 6 11 7 1. So 1 7 1 6 1 minus 1 by 2 plus 1 7 1 6 1 plus 1 by 2. 1 7 1 6 0 by 2 plus 1 7 1 6 2 by 2. 8 5 8 0 plus 8 5 181. So these are the two consecutive numbers. On adding these two consecutive numbers, we will get 131 square. 11th sum. Find the product of the following numbers using square numbers. For this, we are going to use an identity which is very familiar to us. A square minus B square, which can be written as A plus B into A minus B. This is what we are going to use here. A. Find the product of 23 and 25. So we need to multiply 23 and 25. For this, what is the near number for 23 and 25? 24. 24 minus 1 gives us 23 and 24 plus 1 gives us 25. A minus B into A plus B. What? A square minus B square. 24 square minus 1 square. What is 24 square? We can find it over here. 4 4 is 16, 4 is 8, 9, 8, 4. 576. 576 minus 1, which is 575, is our answer. B. 27 into 29. 28 is a number between 27 and 29. So 28 minus 1 into 28 plus 1. A minus B whole square. A square minus B square. 28 into 28. 8 8 is 64. 8 2 is 16. 16 plus 6. 22. 8 2 is 16. 2 2 is 4. 4 plus 1. 5. 784. 784 minus 1. 784 minus 1, that is 783. C subdivision. 36 into 38. 37 is a common number between 36 and 38. So 37 minus 1 into 37 plus 1. A plus B into A minus B. So 37 square minus 1 square. 37 square. We need to find 37 into 37. 7 7s are 49. 7 3s are 21. 21 plus 4, 25. 7 3s are 21. 3 3s are 9. 9 plus 1, 10. 1 2 6 9. 1 2 6 9 minus 1, which is 1 2 6 8. Verify it again. 7 7s are 49. 7 3s are 21. 21 plus 4, 25. 3 7s are 21. 3 6s are 9. 9 plus 2 is 11. And so 1369. So small change here. 1369 minus 1. 1369 minus 1 is 1368. D. Between multiplication of 99 and 101, nearest number is 100. 100 minus 1 is 99. And 100 plus 1 is 101. So A plus B into A minus B is A square minus B square. So 1 2 3 4 minus 1. 10,000, which is 10,000 minus 1 is 9,999. Are you clear with this? Shall we move on to the next sum? 12th sum. Find the squares of the following numbers using the pattern A into A plus 1 in hundreds plus 25. Since last digit is 5, we are going to use that method. 225 square is equal to, here the first number is 225. A plus 1 is 226 times 100 plus 25. 225 into 226. 225 into 2. Sorry. Made a mistake. 225 whole square is equal to, here last we have to leave the last digit and we should take A as the remaining two digits. So 22 is A and 22 plus 1 hundreds plus 25. So 22 into 23 hundreds plus 25. 22 into 23. 46, 46, 506. So 50600 plus 25, which is equal to 50625. They asked us to verify our answer. So we can multiply 225 into 225. 5 5 is 25, 5 2 is 10, 11, 12. 10 plus 1 is 11. 10, 4, 5, the 4. 10, 4, 5, the 4. 5, 2, 6, 10, 5, 5065. It is verified. B. 215 whole square, which is equal to 21 into 21 plus 1 hundreds plus 25 equal to 21 into 22 100 plus 25. 21 into 22 2 4 2 4 4 6 2 4 6 2. Since it is 100, you have to add 2 zeros into 20 plus 25 is equal to 4 6 2 2 5. 215. We are going to verify this. 215. 5 5 is at 25. 5 into 1 5. 5 plus 2 is 7. 5 2 is at 10. 5 1 2 34. 5 12 2 3 4 5 6 4 6 2 2 5. It is verified. We don't have enough space, so we can duplicate it. C subdivision. 355 square is equal to 35 into 35 plus 100 plus 25. 35 into 36 100 plus 25. 36 into 35. 6 is a 30. 15 plus 3 is 18. 6 3s are 18. 3 3s are 9. 9 plus 1 10. 1 2 6 0. 1 2 6 0. Since it is 100, you have to add 2 zeros in last plus 25. The answer is 1 2 6 0 2 5. They asked us to verify it, so we need to multiply 355 into 355. 5 5 is 25, 5 5 is 25, 26 27, 2 15 16 17, 5 7 7 1, 3 5 is 15, 15 plus 1 16, 9 10, 5 12, 14 plus 6 20, 6 14 plus 2 16, 2 1 2 6 0 2 5. D. 405 square is equal to 40 into 40 plus 100 plus 25 is equal to 40 into 4100 plus 25. 16 4 0 2 zeros in front, since it is mentioned as 100 plus 25, which is equal to 164025. We need to multiply 405 into 405. 5 5s are 25, 5 4s are 20, 4 5s are 20, 4 4s are 16. 164025. Is it clear? 13th sum. Find the triangular numbers succeeding 15 and use a dot pattern to show that the sum of 15 and its succeeding number is a square number. So first is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5. There is a pattern. We need to add 2 for first, and then plus 3, and then plus 4, and then plus 5, 15, then plus 6 becomes 21. So find the triangular number succeeding 15. Succeeding 15 is succeeding 15 is 21. Use dot pattern to show that the sum of 15 and its succeeding triangular number is a square number. 15 plus 21 is 36, which is 6 square. So you represented the dot method and verify this. 14 sum. Write the Pythagorean triplet with the following numbers. So with 8, what are the possibilities of a Pythagorean triplet? Is there any shortcut for this? Yes, we have a Pythagorean triplet 2m whole square plus m square minus 1 whole square is equal to m square plus 1 whole square. If this is the case, then our number is a square number. Sorry, Pythagorean triplet. For first, let us consider 2m is equal to the numbers be 2m m square minus 1 and m square plus 1. So here 2m is equal to 8, m is equal to 4. Substitute our answer. 8, 4 square minus 1 and 4 square plus 1. 8, 16 minus 1 is 15 and 4 square plus 1. 16 plus 1 is 17. So 15 square is 225. 225 plus 8. 225 plus 64. 289. 17 square is 289. This is also possible. B. Let us consider what? Here 2m as again 12, m equal to 6. So substitute here 2m, m square minus 1 and m square plus 1. You will get the correct answer. So 2 into 6 is 12. 6 square 36 minus 1. 36 minus 1 is 35. 36 plus 1 is 37. So book answer might vary. You can try what other possibilities are possible. Okay. Again, I'm going to substitute 2m as 14. M is equal to 7. So our numbers are 2m, m square minus 1 and m square plus 1. So 14. 49 minus 1, 48. 49 plus 1, 50. C. Sorry, C completed. D. 2m is equal to 16. M is equal to 8. So our numbers 2m, m square minus 1 and m square plus 1. 2 into 8 is 16. 64 minus 1 is 63 and 64 plus 1 is 65. E. 18. So we can consider 2m as 18. M is equal to 9. 18 by 2 is 9. So our required numbers are 2m, m square minus 1 and m square plus 1. 2 into 9 is 18. 9 square minus 1. 81 minus 1 is 80. 81 plus 1 is 82. Is it clear? 15th sum. Write the Pythagorean triplet whose smallest number among this 2m, m square minus 1 and m square plus 1. Which is the smallest number? Yeah, right. 2m is the smallest number. Let the three numbers be 2m, m square minus 1 and m square plus 1. Smallest number is 20. Therefore, 2m is equal to 20. M is equal to 20 divided by 2. M is equal to 10. Other numbers we need to find. Other numbers are m square minus 1 and m square plus 1. 10 square minus 1 and 10 square plus 1. So 100 minus 1 is 99 and 100 plus 1 is 101. Therefore, triplet is 20, 99 and 101. 16th sum. Find the third number to complete the Pythagorean triplet. You can write like this. 5 square plus 12 square is equal to what? X square. 25 plus 144 is equal to x square. X square equal to 169. X is equal to 13. So the third number is 13. Third number is 13. By Pythagoras theorem we apply. Hypotenuse square is equal to sum of squares of other two sides. Like A, B, C. It's a right angle triangle. A square equal to B square plus C square. We have substituted this directly. 17th sum. Check whether 17, 19 and 34 form a Pythagorean triplet. So 17 square plus 19 square is equal to 17 square is 289. 19 square, 19 into 19, 81, 171, 361 plus 361 equal to 0, 15, 650. On squaring 34 into 34, 4 was a 16, 12, 13, 12, 9, 10, 1156, 1156. 17 square plus 19 square is not equal to 34 square. Therefore, 17, 19 and 34 are not Pythagorean triplet. With this, chapter 3 squares and square root I Enrich 1 completed. If you have any doubt, can ask in comment section. Subscribe to Enrich Ganitha and share it with your friends. See you in another video. Take care.